Hi friends, my name is Saitaya. I'm from CSCD. Topic that we are going to discuss is finding reusable UML sequence diagrams automatically. The topic is from the subject object-oriented software engineering. Let's go through it. Introduction. Reuse in software intensive systems is ubiquitous practice. In general, software reuse is defined as the process of creating software systems from existing software. Software reuse does more than improve productivity in software development. It also increases the quality of the resulting software systems because it uses validated artifacts. Requirements engineers benefits from reuse, even though it's a manual process relying on human recall in most situations. Analysts can recall prior specifications, adapt them to the current problem, and consolidate the reusable parts to create new requirement specifications. Artifact reuse. Software analysts create many artifacts and often recall prior works as they recreate new artifacts. For example, when presented with an e-commerce problem, they create yet another e-commerce solution. This process needs to improve. Design by pattern is popular approach in which analysts create designs by instantiating predefined patterns from books or from computer-aided software engineering tools. But analysts find their own personalized designs much more most useful, and these are not generalized into patterns. Rather than instantiate the pattern, like analysts copy and adapt their existing artifacts. Until recently, such artifacts reuse has been cumbersome. To demonstrate, let's let's walk through the process of defining an online sales system. Many analysts begin a sequence diagram similar to that shown in the illustrated fragment is a common sequence diagram, but this is just the beginning. Analysts which also typically develop use case text. The class diagram and more complex sequence diagram having developed such systems before, many analysts retrieve related UML artifacts and copy and edit them as necessary. This manual strategy works well for small set of predefined designs. However, the strategy breaks down when the design library contains more designs produced by different analysts. It becomes difficult and time consuming to know the library scope as well as to find the best matching artifacts. Some automated design retrieval approaches exist. However, they require specific design annotations which most analysts are unwilling to add or reuse tools lets analysts automatically retrieve created artifacts for reuse. Unlike other reuse approaches, this approach relies on the artifact structures and less than extra artifact annotations or name similarity. And this is the diagram which we can see step approach of new sale, create UML structures. Reuse assists the reuse of UML artifacts, including use cases, class diagrams, and sequence diagrams. In this in this article, we focus on sequence diagrams reuse figure. For example, shown a partially completed sequence diagram, pass it to the tool. Illustrates the reuse tool finding matches for figure A query. An analyst can browse the list of the best matches and directly open artifact from the list. The selected match must then be adapted to satisfy the current problem. The figure shows sequence diagrams displayed as text strings of their object and messages matched artifacts as shown as in. indented below their initiated query, illustrates that reuse can find multiple artifacts for the single query. You can reuse artifacts using UML extensions reuse automatically unless UML extensions are an extended use case diagram. In this diagram, an administrator in an UML actor, which is rational unified process stereotype of business work. Similarly, the update user use case makes use of the RUP stereotype to goals that the use case supports: update user info and maintain user info. These are displayed with the user defined stereotype. Similar sequence diagrams for the use case. The automate authenticated user object in the sequence diagram is an instance of a subclass of the administrator class from the use case diagram. The two diagrams are interrelated and represent an initial use case stretch. Together, they form an artifact fragment which is used to query the artifact library. So here is the diagram. We can go through it. Automated encoding. Rather than you analyze the UML artifact directly, reuse analyzer, a direct graph representation, reuse translates UML artigraphs into its internal representation by translating UML meta model elements into directed graph. By translating meta model types into vertical vertex types, the approach applies to the UML versions, including version 2.0. UML meta model associates because become edges in the internal graphs, which all other UML meta model elements become vertices. Using vertex prefixes maintains as part of the translation UML meta model elements types, including UML extensions such as stereotypes, the result of UML artifacts, minimal graph type presentation. Consider UML artifact classes, objects, messages, stereotypes, and so on are encoded as vertices. UML associates and links become edges. A class instance, for example, becomes a vertex prefixed in with ins, and a class is prefixed with cls. A message vertex prefixed with message is located between its sending object and receiving object vertices. Edges represent UML metamodel associated associations, including the following diagram. Conclusion. However, with this polymeta polynomial time algorithm, use doesn't perform well with large query structures. In such cases, analysts can obtain good results by reducing the query size, for example, by leaving out the final subsequence from a sequence diagram. Expert analysis can obtain every even better results by modifying the parameters to the underlying subdue algorithm, such as search breadth, limit, and target structure size. Other approaches to reuse suffer similar or worse program problems of scale. All approaches define a similar metric. However, most often the approaches only use the metrics to group artifacts. Fewer reuse approaches use their metrics to define an efficient concept lattice. Moreover, more approaches rely on extra artifacts, annotations to guide matching. A library concept lattice constructed from a library specific metrics might be an efficient approach. However, few organizations will pay for such customizations, and few analysts are willing to work with the extra artifact annotations. Although reuse supports dynamic customized query, it doesn't support weighted among the criteria. To define a customer query, an analyst can include custom elements in the query structure. Similar library structure will match. However, an analyst might deem certain elements or associations central to the query. Future work will support weighted query graphs. We base and reuse automatic classifications on structural design common- commonalities. Thus, we can mine we can mine pattern from the library lattice. You might consider the more abstract, more accepted common patterns as empirical design patterns. Comparing such empirical patterns with the many descriptive patterns currently espoused could produce interesting results. In the meantime, analysts can improve their process quality and efficiency by applying reused structural relationship retrieving approach. Thank you.